This is the demo that accompanies the lesson on SQL Server Failover Clustering fundamentals. What you're seeing here is the diagram of the basis of what I'm going to do in my demo. So keep this diagram in mind as I move along. Standard 2-node Windows Server Failover cluster, and I'll be installing SQL Server 2012 on top of it. What you're seeing here is the cluster preparation checklist that I've shown you in the lecture portion of this topic. I strongly recommend that you prepare everything that you need prior to installing and configuring a SQL Server Failover clustered instance. It makes the whole process a lot easier, especially if you plan ahead. I have the first tab here, the list of servers that will act as nodes in my Windows Server Failover cluster. So I've got the Windows Server and versions and editions, the host names, capacity for CPU and available memory, and which domain these servers belong to. In a Windows Server Failover cluster, the server nodes have to be a member of the same Active Directory domain. You see me using Windows Server 2012 Data Center Edition, although with Windows Server 2012 you can use Standard Edition for your traditional Windows Server Failover cluster. This is unlike in previous versions of Windows 2008, 2003, where you have to use the Enterprise Edition for spinning up a Windows Server Failover cluster. In my network tab, I have all the IP addresses, TCP/IP configuration for my entire cluster. I've got my public network, IP addresses, subnet, gateway for my public network. I'm using iSCSI for my shared storage, and that's why you're seeing iSCSI IP addresses. Win Cluster 2 will have its own virtual IP address. Now, imagine that these two machines are in the same data center, in the same network segment, and that is why you're seeing IP address in the same network subnet range. In the next video, I'm going to show you how you can provision geographically dispersed clusters where nodes are in different data centers. But in this case, since I'm only dealing with cluster nodes in the same network subnet, I only need one virtual IP address. This will be the virtual server name for my standard SQL Server Failover clustered instance, or the traditional failover clustered instance, and it will require its own virtual IP address as well. For the shared storage tab, I'll be provisioning a Quorum disk and my SQL Server data disk. These are shared storage, and I'll be using local storage for tempdb, something new in SQL Server 2012, unlike in previous versions of SQL Server where everything has to be on a shared drive. Now, this is not best practice. The best practice is always provision independent LUNs for your data drive or your data files, your log files, your backups. But again, I'm just highlighting the fact that we need to have shared storage to install SQL Server Failover clustered instances. On the Clustered Services tab, I have my clustered application, in this case SQL Server Failover cluster, with its virtual server name and virtual IP address. I'm using Enterprise Edition for my traditional failover clustered instance, but you can use Standard Edition as well with a limit of 2 nodes for that failover clustered instance. The reason I'm using Enterprise Edition for this purpose is later on I might introduce always on availability groups for this instance and make this as a replica for that availability group. But let's worry about that later. For now, I just want to spin up a 2-node SQL Server Failover clustered instance. And then I have my service accounts. These are the service accounts that I'll use for my SQL Server service and SQL Server agent service. So I have access to WS Cluster 3 and WS Cluster 4. The first thing that you need to make sure of is enable the Windows Server Failover Clustering feature on all of the nodes of your failover cluster. Now to do that, you click on the Add Roles and Features wizard. Click Next until you find the Select Features option. Note that I've already enabled the failover clustering feature. And as I mentioned, even before you create the Windows Server Failover Cluster, this feature has to be turned on all of the nodes. I've also installed, if you notice, the .NET Framework 3.5, and the reason I already did this is it's a prerequisite for installing SQL Server 2012. So I've already done this, and I've already configured storage for both of my cluster nodes. Now, this is not a course on how to configure your storage. I just made sure that my nodes are already connected to my shared storage. If you're a SAN engineer as well, there are different ways to connect to your shared storage, and of course there will be different methods to connect to your shared storage depending on what type of shared storage you're using. In this case, since I'm using iSCSI storage, I'm using the iSCSI initiator console to connect to my shared storage. My shared storage is already provisioned, and you can see it in my disk management console. So drive Q and drive F will be my shared storage, and these are also accessible to WS Cluster 4, which is the other node in my cluster. Drive E is a local drive, and like I said, I'm going to show you how to install tempdb in a local drive as compared to the previous versions of SQL where you can only put tempdb on shared storage. Since I've already done that, the next thing that I need to do is configure my Windows Server Failover Cluster. So we're going to be using the Failover Cluster Manager for this purpose. Once my Failover Cluster Manager is up and running, I will be validating my cluster. So this is where the validate configuration wizard comes into the picture. You run validate configuration for new cluster preparation, or if you're adding another node or replacing a hardware in your cluster. Just want to walk you through the process of running the Failover Cluster Validation Wizard. So you see the splash screen. It'll ask for the servers that you want to join as nodes in this cluster, in this case WS Clusters 3. So I'm going to add both WS Clusters 3 and WS Cluster 4 in the Validate a Configuration Wizard. And this is one of the things that we talked about in the lesson portion, where you have to do this in order for your servers to be completely supported by Microsoft. Click Next. By default, the option Run All Tests Recommended is the one selected. But I want to show you the different tests that this wizard will run. So I'm going to click Run Only the Tests I select. Part of the test will be inventory. It's going to check your storage. It will check your system for BIOS information, system software. It'll check your network for binding order, the IP configuration. It'll check your storage, whether or not your storage are indeed supported for Windows Server Failover Cluster, and then system configuration. It'll validate Active Directory configuration, some drivers, software patches, and so on and so on. If you're building a new cluster, I strongly recommend that you choose the first option, Run All Tests. And the only reason I clicked on Run Only Tests I select is just to show you what different tests are being run. Now, if you add a node, you can choose to run only the tests that you want and validate the cluster based on that. But since this is a new cluster, I'm going to run all the tests. And this is where the validation testing will start. So I'm going to click on Next, and the testing will run. Now, this will take quite a while depending on the number of drives that you have for your shared storage, depending on the number of nodes that you have that you will provision for your cluster. In this case, I only have like 2 drives and 2 cluster nodes. So I'm going to pause the video and return when this entire validation process completes. So the validated configuration wizard is complete. If you look closely at my summary icon, it just tells me that everything ran successfully. If there are issues with running the configuration wizard, you'll see a warning or an error icon in the summary on the upper left-hand corner. You can view the report or the detailed report of the different tasks and tests that the validation wizard ran. And again, this will show you a summary. In some cases, you might see under system configuration a warning telling you that the patches on one node is not exactly the same as the other node. Again, if these are warnings that you understand, you can skip them. If you're seeing errors, you can't create a Windows Server Failover cluster. You have to fix the errors first, rerun the cluster validation, and then move on. Use this as part of your documentation. You can copy this off, save it in a Word document, put it in your runbook as a reference for the failover cluster validation. Now, when I click on the Finish button, notice that I have the Create the Cluster Now using the Validated Nodes checkbox. By default, this is checked so that when you click on Finish, it will now ask you to provision information about the Windows Server Failover Cluster virtual computer object name and a virtual IP address. So let me click on Finish, and this will fire up the Create Cluster Wizard. Click Next on the splash screen. It will ask you for the virtual computer object name of the Windows Server Failover cluster. In this case, we know it's Windows Win Cluster 2. And I want to refer back to my Excel spreadsheet. I know that my Win Cluster 2 server will have an IP address of 172.16.0.211. Notice that it also detected that you only have one network subnet and thus asking for only one virtual IP address. Click on Next to create the Windows Server Failover cluster. Of course, it's going to ask you for the other information like the cluster name, the nodes that will be a part of this cluster, and the virtual IP address. Notice that you have this checkbox. Add all eligible storage to the cluster. By default, it will add all of the shared storage into the new Windows Server Failover cluster. Now, you might not want that, but I would strongly recommend it. You only present the storage that you want to include in your cluster on those nodes so that the cluster Create Cluster Wizard only considers those storage as part of the cluster. Click Next, and this will create the Windows Server Failover cluster. Now let me switch to my Active Directory machine here and show you that I only have Win Cluster 1, which is already there. I just use it as an example in my Active Directory users and computers console under the computers folder. Once the Windows Server Failover cluster is created, you will see Win Cluster 2 in the list. And I'm going to refresh this real quick. And now you see Win Cluster 2 in the list of machines in my Active Directory domain. As I mentioned in the lesson, when you create a Windows Server Failover cluster and even a SQL Server Failover clustered instance, the virtual computer object will be created inside Active Directory. Same thing with DNS. I don't have Win Cluster 2 yet here, but when I hit refresh, of course, this assumes that you have an Active Directory integrated DNS zone. So now I have Win Cluster 2 in the list as well with the virtual IP address that I've specified in my Windows Server Failover cluster. Most people ask what are different permissions that I need to create a Windows Server Failover cluster and install a SQL Server Failover clustered instance. Well, for one, you have to have a create computer object permission in your Active Directory. So you have to talk to your Active Directory domain administrators for that. Let me go back to my WS Cluster 3 node, and this is where the Create Cluster Wizard has created a cluster with the corresponding virtual server name and the virtual IP address. Again, you can click on View Report to see the different tasks that the cluster has done for you. And again, similar to the Failover Cluster Validation Wizard report, I strongly recommend that you take this and paste it in a Word document and include it in your runbook for reference. Let's click on Finish. We now have a Windows Server Failover Cluster inside our Failover Cluster Manager. The cluster will now be managed via Failover Cluster Manager, and of course you can also use Windows PowerShell for managing the cluster. What you'll see in here is quorum configuration. You have a node in disk majority, the traditional node in disk majority for a 2-node cluster, and a shared drive acting as a quorum drive. You can expand on the cluster core resources when cluster 2 is your virtual server name and your virtual IP address. Cluster storage that is used for this particular cluster is cluster disk 2. It's not that intuitive. It's just going to use the default name. So cluster disk 2, cluster disk 3. After doing so, I strongly recommend that you rename the storage appropriately so that you don't get confused with these. So disks, I have cluster disk 1 and cluster disk 2. It's kind of hard to see what they are, but in this case, since I know that my 4 GB will be my SQL Server cluster drive, cluster disk 2 is my quorum drive. So why don't I change the properties of my cluster disk and rename them accordingly. Apply, and this of course will be my SQL Server drive. The same thing with your network. If you look at this closely, cluster network 1, cluster network 2, not really that intuitive, but because I've renamed my network adapters from within my Windows server nodes, it's easy for me to identify which networks these are. So I'm going to rename them accordingly and say this is a heartbeat network. And notice that I have the option to either allow cluster network communication in this network. I'll use the default options. This one is for my iSCSI. And notice that it did select that do not allow cluster network communications because it's smart enough to figure out that this is not available on the network. I'm using iSCSI for this, as well as my public network. So I'll probably name this LAN. And notice that I have the option to allow clients to connect through this network. It's smart enough to see that this particular network adapter is connected to my public network, connected to my Active Directory, and this will be the network adapter that will be used for application connectivity to your cluster. Click OK. Going back to the cluster configuration, I'm using node in disk majority. There are cases when Windows Server Failover Cluster will see this particular disk list of disks and will just pick up the first disk that it sees. So what if you don't like that? You can go ahead and configure, say, more actions, configure cluster quorum settings, and you can change the disk that you want to use as the quorum disk. Say, add or change the quorum witness, configure a disk witness. Again, the assumption here is you didn't really like the idea of the cluster using the other drive because, well, we only need like 512 megabytes for your quorum drive, but it picked the 20 gigabytes or the 400 gigabytes drive. So you can change it by doing so. And I can switch to the SQL drive or the other drive that you want to use for your quorum disk. But in this case, it's smart enough, or let's just say I know that this is going to happen, so I added the quorum disk first before adding the data disk. Now that's done, you can verify everything if they're working, the storage. This is what I was mentioning earlier about the different names. Roles started out as resource groups in earlier versions of Windows, changed to services and applications in Windows Server 2008, and now they changed it to roles. Currently, we don't have anything yet in this particular cluster, but I would strongly recommend it once everything has been configured, because now you have a working Windows Server Failover cluster. You can now access this cluster by using WinCluster2 and start failing over and failing back, maybe shutting down one of the nodes or unplugging network adapters and validating that this cluster is indeed highly available before you even install SQL Server. Once everything's done, I can now go ahead and install SQL Server. Notice I don't have my cluster drives here. I only have my system partition, my temp.db, which is my local drive. If you look at the disks, they're owned by WS Cluster 4. Now I can move these, say move this to, or one of the things that you can take a look at is show the dependency report. We're gonna dive deeper into the dependency report once I have everything up and running with SQL Server installed as a clustered resource on this particular Windows Server Failover cluster. In this case, I don't really have any dependency at all. So I can try and show you later on how this entire dependency works. So now let's go ahead and install SQL Server in this particular cluster. I'm using the RTM version of SQL Server for this particular installation so that I can show you how to patch the nodes in a clustered SQL Server instance. You do have the option to download and install the SQL Server 2012 installation media with Service Pack 1 included. And you can also use the product updates feature that's new in SQL Server 2012. And again, the only reason I'm doing the RTM version of the installation media is I want to show you how you can configure patching, or how you can perform patching in a clustered SQL Server instance. Let me minimize this for a while because I don't need them. And wait until my installation media starts. So when the installation window kicks in, you want to take a look at the installation tab. The usual option that we select when installing SQL Server standalone instance is the first option, but since we are going to install a SQL Server Failover clustered installation, we have to choose the second option. Just be aware of the fact that you can't convert a standalone instance to a clustered instance and vice versa. So you have to be very careful when you're doing this installation. So select the new SQL Server Failover cluster installation. So the setup support rules window kicks in and checks for the different configuration, making sure that everything is set and okay before moving on with the installation process. Once that's complete, click on OK. And again, you will be presented with different options and maybe different settings that you need to resolve prior to moving forward. If, for example, .NET 3.5 Service Pack 1 is not installed, this will be reported as an error, so you have to fix that first before you move further. It's one of the reasons why I've added the .NET Framework 3.5, and I've shown you that when I was adding the failover clustering feature in Windows. Now, this is a new option in SQL Server 2012. As I was mentioning earlier, if you are not using the latest installation media with SQL Server 2012 Service Pack 1, this is a new option to choose. Now, what this thing does is if your servers are connected to the internet, it will go out to Windows Update, Microsoft Update, checks for corresponding service packs, cumulative updates, and security patches for this particular version of Windows, and downloads them and installs them together with the installation process. In this case, I don't have my machines connected to the internet, so I'm skipping this portion. Click Next. Still running some checks. Now this portion will check the other tasks that you need to fix as part of your setup. You probably notice this warning over here on the distributed transaction coordinator. So I mentioned, I know that I'm not going to be using the distributed transaction coordinator for the SQL Server instance, so I have not configured that. Windows Firewall, if you have a corporate policy to turn this thing on, just make sure that you allow port 1433 traffic and 1434 for your cluster. Just scrolling through the different warnings. And again, similar to the previous setup support rules check, you can't get past this until you fix some of the errors. I'm only ignoring the warnings because I know what they are, and I know that I don't need to resolve them. So I can click on Next. Now, of course, I did skip past the page where I provide my product key. You wouldn't want to see my product key, do you? Click Next. Click Next in the SQL Server feature installation. For this clustered instance, I only need a database engine. So the first option, the SQL Server feature installation, by default is selected. And when I go to the next page, I'm presented with the different options. I like to keep my SQL Server instances lean and mean and with minimal services and components running. So since I'm only going to be using this for the database engine, I will select the database engine services. By default, it will select the replication and full text and semantic extraction search. I'll also include documentation and management studio in my installation. Again, one of those rule checks. It asks me for the SQL Server Failover Clustered instance name. Now, this will be the virtual computer object, virtual server name that will be created in Active Directory. So I'm going to provide this network name. And again, since this is a default instance, I'm only going to provide a virtual server name. If it would be a named instance, I can choose to select the named instance option and provide the instance name. But again, this is the first instance in this particular cluster. I can choose the default instance. Click Next on the disk space requirements. In the cluster resource group page, it will ask you for the resource group name that you would see in the roles portion in your Failover Cluster Manager. Again, resource group is what I prefer calling it, but now it's called roles. So you have by default are provided with SQL Server, MS SQL Server. Be intuitive with the naming. I choose to use the default name or the resource group name because this is the only SQL Server instance that I will run in this cluster. And don't get ticked off by the drop-down list. You can actually edit this if you want to and use a different name. This page displays the different disk resources that are visible on my Windows Server Failover cluster. Note that the quorum disk is no longer available because it's being used as my quorum drive, but the SQL drive, F drive, is still available, so I can choose to select that. Now, if there are other shared disks available in the cluster, you would see them here as well, and you can select those disks that you want to use or not use with a SQL Server instance. In the cluster network configuration page, you'll be presented with this option, and you can choose to type in the virtual IP address. And this is the value that you see me include in my cluster preparation checklist spreadsheet. Now, since, again, as I mentioned, this is a cluster with nodes in the same data center and the same network subnet, you'll only see one IP subnet range here. If you have multiple nodes in different network subnets, you would see multiple IP addresses for the virtual server name. In this case, I only have one network subnet, so I only need one virtual IP address. In the next video demo, I'm going to show you where a cluster with multiple nodes in different network subnets will present you with a page with multiple options to fill in various virtual IP addresses for different network subnets. In the server configuration tab or page, this is where you provide a SQL Server service account. And I just want to make sure that I copy this. I'm using the same service account for my agent service in my database engine. A couple of things I want to point out here is the sequence of the services that are presented to you in this window. Kind of annoying. You'll see agent and database engine in that sequence, but when you start adding nodes, you'll see database engine first before agent. Why am I highlighting that? Because there may be cases where you want to use a different service account for the agent and the database engine. In this case, it doesn't really matter because I'm using the same service account. But again, in case you choose a different service account, be very careful of what particular service account that you use for that engine. And you'll see that later when I start adding nodes. Note the startup type for both services. They're configured as a manual, and the reason for that is the Windows Server Failover Cluster will take care of when the services will stop or start. So I'm gonna keep those as they are. Collation, I'll keep it as it is, depending on what type of collation that you want for the SQL Server instance. For example, if you want to use this clustered instance for your SharePoint databases, you might want to use the specific collation for this instance. I'll click on Next. In the server configuration tab, I want to make sure that I can manage this instance, and so I'm going to add my domain account. In my data directories tab, I'm provided with a different directory. Now for the temp DB, as I mentioned, I want to store my temp DB in my E drive. And this is a local drive. When I click Next, and I want to make sure that everything is correct, so my data directory is on the F drive, whereas my temp DB database will be on my local drive. And as I mentioned, you will be prompted with this message saying you have specified a local directory as the tempdb data or log directory. Now, keep in mind, in previous versions of SQL Server, you only have the option to store tempdb in the shared drive. This is new in SQL Server 2012. But I want to point you out to this specific message. It says to avoid possible failures, you make sure that the same directory exists on each cluster node, and make sure that you grant read-write permissions to the SQL Server service. This is something to keep in mind, and I'll show you that when we start adding the extra node into this cluster. So I'll click Yes. Click Next on the error reporting page. Again, the last cluster installation rules page. Want to make sure that everything is fine. Click Next. And the installation goes. So I'm going to pause the video until this entire thing completes, and I'll come back and install the extra node, WS Cluster 4, and add it to this particular SQL Server instance. So the installation is complete. I can click on Close and verify the installation. Notice that my Roles tab in my Windows Server Failover Cluster Manager now has the cluster resource group that we configured as part of the installation. I want to take a look at some of the information on this specific cluster resource group. I've got my summary, my virtual IP address, and my virtual server name, resources. And this is where I start explaining the concept of dependencies. So I've got my virtual server name and my virtual IP address, my storage, my SQL Server service, and my SQL Server agent. These are all clustered resources inside this clustered resource group. And I want to quickly right-click on SQL Server agent and display or show the dependency report, something to really understand how dependencies work, and very helpful when you're doing troubleshooting for anything that's running on a Windows Server Failover cluster, including but not limited to Windows Server SQL Server Failover clustered instances. So take a look at this graphic. This graphic represents my dependency report. I know that my SQL Server agent is dependent on the SQL Server clustered resource. So in order for me to start a SQL Server agent, I will have to start a SQL Server service first. In this case, it's a clustered resource. My SQL Server clustered resource is dependent on my physical disk, the SQL disk, and my network name. It's an AND condition in this case, which means I have to have both my network name and my clustered disk online before my SQL Server service goes online. Same thing with the network name, which is dependent on the IP address. I would strongly recommend that you copy this, take this entire report, again, copy it on a Word document, print it out, and include it in your runbook. I do not have my second node configured yet. So in this case, if you look at my properties, I don't have the preferred owners yet. I'm going to work on the preferred owners at this point. But since I don't have WS Cluster 4 ready, I can't add it in my preferred owners list. So I'm going to switch to WS Cluster 4 and start the installation. So I'm going to open up my installation media. Same process, but this time I'm going to use the third option to install or add a node to an existing SQL Server Failover clustered instance. Now you'll see the same installation process here, except this time we'll be choosing the third option to add a node to an existing SQL Server Failover cluster. You're gonna do this on all of the nodes that you want to be a part of your SQL Server Failover clustered instance. So I'm going to choose that. There will be the same screenshots and same windows and same dialog boxes that you'll see in this process, except that they all pertain to adding a node to an existing failover clustered instance. So the same setup support rules. Again, I've skipped past the page where it asks for my product key. Click next. Again, I'll not include SQL Server product updates because this server also doesn't have any connection to the internet. Besides, I don't want to have one node on one version and another node on a different version. I want to make sure that they're all uniform as far as version numbers are concerned. And I can ignore this because, again, it couldn't connect to the internet. Same rule check that you've seen when I was installing the failover clustered instance on the first node. Same warnings, I would presume: distributed transaction coordinator, Windows firewall, and my Microsoft.NET application security. Notice that it already sees the instance name. It's running on my existing Windows Server Failover cluster. The cluster network name is SQL 2012 Clus 2. So all this is doing is simply adding WS Cluster 4 to the existing cluster. cluster network configuration page detects the virtual IP address that we've provided when we were installing the SQL Server Failover Clustered instance. We no longer have to do anything at this point. But again, if this machine is on a different network subnet, you'll be provided with another IP address line, and you have to provide the virtual IP address for that network subnet. In this case, we'll just have to click Next. This is what I was mentioning earlier, and I want you to pay attention to this. Notice the sequence of how these services are arranged in the previous node where we started installing the SQL Server Failover Clustered instance. The SQL Server agent came in first before the database engine. If, again, you're using different service accounts for the database engine and the SQL Server agent service, be very careful of this. In my case, they're the same. So I'm just going to provide a password for the SQL Server service accounts. Click Next. Click Next on the error reporting page. Last, rule check. Again, make sure that everything passes the rule check. Click Next. And proceed with the installation. This will also take quite a while, so I'm going to pause the video and come back once this is done. And the add a failover cluster node process is successfully completed. We can now verify the installation. Now, before I do that, one thing that I need to do is to make sure that I have a new folder in here called MS SQL. Remember, we configured our TempDB database to use the local E drive. Since I have the same drive letter, I want to make sure that I have the same drive letter on both nodes. I have to have the right folder, the right path on which to create the TempDB database. And I also need to grant a SQL Server service account read-write permissions on this folder. So I'm going to add the SQL Server service account. Grant full control permission. You can do modify if you want to. The last time I did this modify, it wasn't enough, so I'm usually granting this service account full control permissions. And this is part of the failed process testing, because when you fail over the TempDB database, it's going to get created on this particular folder. Now I want to switch to WS cluster 3, which was the cluster node that I initially had the SQL Server Failover Clustered instance run. I want to do a quick refresh. Now I can configure this resource group and make sure that I have the appropriate permissions and configuration for that resource group. I'm going to right click on the resource group, click on properties. I want to make sure that both nodes are my preferred owners. I want to make sure that my priority is set to high. This is useful when you're running Hyper-V in this cluster, but in this case it's the only resource that I'm running. I want to make sure that it is configured with high priority. Click apply. Now I want to point out how the dependency works by moving this resource, currently being owned by WS cluster 3, to cluster 4. And as I'm moving the resource group, I want you to pay attention to the different resources and their dependencies and how they behave. So when I click on OK, the SQL Server agent is first taken offline, then the SQL Server service is taken offline, and then the SQL storage, the F drive, is taken offline and then brought offline. Note that the virtual server name waited until the IP address or the virtual IP address went online before it became online. And same thing with the SQL Server service. It waited for the virtual server name to come online. Of course, this was already online before the virtual server name became online, before it was brought online. And so this is where the dependency comes in. Going back to the dependency report that we were looking at. Now my resource is owned by WS Cluster 4, and you've seen how the behavior works as far as dependencies are concerned. I want to go to WS Cluster 4 and show you that now my TempDB database is now created on the E drive on the MS SQL folder. And I can do the exact same thing and fail back to WS Cluster 3. So I've created my folder, I've granted permissions to the SQL Server service, I've managed to do a failover test, and so my application or my SQL Server clustered instance is now properly configured. Well, as far as the cluster is concerned, of course. I'm going to move this back to WS Cluster 3 again. Notice how the behavior with the agent, the service, the drive, the virtual IP address, and the virtual server name and how they behave. The reason I'm highlighting this is it is very important to understand how the whole dependencies work and how the failover and failback works in a clustered environment, because you will be using this information when you're doing troubleshooting. Let's verify if we can connect to this particular instance using SQL Server Management Studio. So I'm going to open up my Management Studio, connect to my SQL Server database engine, verify that everything is working fine. Again, part of your failover and failback test is making sure that your applications can connect to your database engine. Notice my version number, 11.0.2100. This is the SQL Server version that I'm currently running on, RTM version. So the next thing that we need to do after the cluster is done is to install Service Pack 1. But before I do that, I want to go back to my Active Directory environment and show you the computer objects that have been created. So when we created a cluster, when cluster 2 was created, and when we installed the SQL Server Failover Clustered instance, SQL 2012 Clus 2 is now in my Active Directory computers list. And of course, my DNS is configured with Active Directory Integrated Zone. This entry is also created in my DNS. I'll do a quick refresh, and now I have SQL 2012 Clus 2 with the IP address that I've provided earlier. So this is how you'll see the integration between SQL Server Failover Clustered instance running on Windows Server Failover Cluster and Active Directory with DNS. So as I mentioned, the next thing to do is to install the Service Pack. If you go back to the lesson, the Service Pack installation has to be done on the node that is not running any of the clustered resource groups. In this case, if I look at my Windows Failover Cluster Manager, the resource is currently running on WS Cluster 3. So what I'll do is I'll install the Service Pack on WS Cluster 4, and once that's patched, I am going to move the clustered resource from WS Cluster 3 to WS Cluster 2. So I'm going to switch to my WS Cluster 4 node and run the Service Pack. I just downloaded the Service Pack and copied it on my WS Cluster 4 node. Again, run the installation bits. This is going to extract the bits into a temporary folder. Now, I want to highlight the reason why the process goes like this. In previous versions of SQL Server, 2005, 2000, when you install a Service Pack on a clustered instance, it will have to go through all of the nodes and cross your fingers, everything works fine. that sometimes introduces a lot of complexities, especially if the installation turned out to be a failure. Downtime is inevitable. In this case, you install the service pack on the non-active node, patch that. If something happens, your SQL Server Failover Clustered instance is still working, not affected. That minimizes downtime. Although the challenge there is if you have multiple instances running on multiple nodes, you would have to do an X times Y times of installation as far as installing the binaries and installing service packs are concerned. So you have to factor that into your operations and administrative overhead down the road. Click on Next. Accept the license terms. By default, the database engine services are selected. Click Next. And this will patch all the components that you've specified. So if you have Management Studio, in this case, I didn't install Management Studio on this node, but it is recommended to do so. It's going to patch that. I'm going to skip past this and click on Next. It's just checking for locked files, and click Update. The service pack installation is on its way. And again, the binaries will be upgraded. The DLLs, the EXEs will be upgraded. Once this is done, we'll switch back to WS Clusters 3, fail over the SQL Server resource group on this node, and then run the service pack on that node. One thing that I didn't do, which I should be doing, is to remove this particular node from my preferred owners group. In this case, again, right-click on my resource group, properties, remove my WS Cluster 4 in my preferred owners so that I don't accidentally fail over to that node. Once the service pack installation is done, we're going to flip this back to WS Cluster 4 as my preferred owner and remove WS Cluster 3 until the service pack is done, and then put it back as it was before. Let's just wait until the service pack has completed installation. I'm going to pause the video again and come back when this is done. So the service pack installation is complete on WS Cluster 4. I'm going to switch to WS Cluster 3 and install the service pack in that particular node. But before I do so, I'm going to move the SQL Server resource group from WS Cluster 3 to WS Cluster 4. So I'm going to close this. And I want to make sure that I have a copy of the service pack on WS Cluster 3. So I want to make sure that I copy this in there. Copy that over. And switch to WS Cluster 3. Similar to what we did earlier, I would now change my preferred owners to only be WS Cluster 4, fail over the cluster resource from WS Cluster 3 to WS Cluster 4, and then remove this from the preferred owners list. Under properties, remove this and make this as my preferred owner. Move that to WS Cluster 4. Now what's happening here is not just your usual failover where the services are brought offline, but in the process, SQL Server will now start upgrading the databases, the master database, the user databases. In this case, I don't have any user databases yet, but part of the process here is when it fails over to WS Cluster 4, it sees that the version is higher than this particular node's version and upgrades the database. And that's why it's taking a while to bring the clustered resource online. Keep this thing in mind, especially when you're doing service pack upgrades or even installing cumulative updates or security patches, because this will factor into how long it takes for your SQL Server resource to go online. And again, if you notice, this is not the same amount of time that it took when I was doing a failover and failback test. So I'll pause the video for a while and come back when the clustered resource has come back online. Notice that the SQL Server resource has just gone online and my SQL Server agent has just gone online. Now I can install the service pack on this particular node. Let me close this. Run the exact same process on WS Cluster 3, and once it's done, we now have a fully patched 2-node SQL Server Failover Clustered instance running on a Windows Server 2012 Failover Clustered instance. Again, click on Next. Accept the license terms. Similar pages as what you've seen in the other node where I installed this particular patch. And click Update. And again, I'm going to come back to this once the service pack has been installed and reconfigure my cluster resource group to make sure that I've got everything covered. And service pack installation is complete. Now keep in mind at this point, WS Cluster 4 still owns the clustered resource group. So we want to make sure that we bring WS Cluster 3 back to the preferred owners list. And if you prefer WS Cluster 3 or this particular node to be the node that will constantly run the SQL Server Failover Clustered instance, you have to move it back to this particular node. Go back to Properties. Make sure that WS Cluster 3 is my preferred owner. Click back and fail back my resource group from WS Cluster 4 to WS Cluster 3. This wouldn't take that long as compared to what happened earlier when we moved the cluster resource group from WS Cluster 3 to WS Cluster 4, primarily because the binaries have taken care of upgrading the database on WS Cluster 4, so this one's a lot quicker. And notice that the SQL Server service is now back online. So we've installed a 2-node SQL Server Failover Clustered instance on a Windows Server 2012 Failover Clustered instance from scratch, configured the clustered resource group, and then installed service pack on top of it. In the next video, I'm going to show you how you can install a SQL Server 2012 Failover Clustered instance that's configured to have nodes across different geographical locations, commonly known as multi-subnet clusters or geographically dispersed clusters.